Good morning, one and all. This is Joseph, working as support JMAG support engineer in PwC Engineering Solutions Private Limited, India. Without wasting our time, we'll start the session. This session basically covers a function tutorial which is based upon the winding editor. So with using this tool, we can set up the winding conditions for 2D and 3D models using the default winding editor in JMAG. So we'll start. So moving to the introduction of PowerSys. PowerSys is having 17 years of vast experience in the field of providing solutions for electrification globally. We have 8 offices around the globe and 40 employees working all over the globe. PowerSys born in France in 2002. With one software, that is PSIM, and later in 2016 we got the distribution rights for distributing JMAG, SIME, and Smart Control. And in 2009 we started our office in USA and Germany. And 2011 we started distributing EMTB software, and in 2013 we started our offices in India in Chennai. So 2015, we started our office in Canada. In 2016, we got the rights to distribute Sabre, and in 17, we got ProLB, and in 2018 and 19, Power4J and Flownex comes into the package of PwSim. So PwSim created in 2018 by the alliance of PowerSys and ProSim. ProSim is an Indian company. So PwSim is the Indian subsidiary of PowerSys. So we have all the advanced software and high-end services related to electrical engineering services. So coming to the electromagnetics, we have JMAG, the first package. It's a comprehensive FEA software suite for electromagnetical equipment design and development, such as electric motor, transformer, and all other devices, which basically uses the principles of electromagnetism. And the second one is MPCCI, an application independent with independent interface for direct coupling of different simulation code. So related to power electronics, we have a wide variety of softwares. The first one is Sabre RD. So for robust design and multi-domain physical system advanced simulation, we can use the software. And coming to the PSIM, we have fast and multiple cycle simulation of converters. So that is possible using PSIM, and we have also smart control in that package. Coming to the system level or multi-physics, we have Sabre AS Designer. That is basically for optimization and safety analysis of EVs in EVs wire harness, and Flownex, which is used for fast, reliable, accurate fluid analysis in subsystem level simulation. Coming to the computational fluid dynamics domain, we have ProLB, Cradle, and related to the grid integration, we have EMTP, a complete technically advanced simulation tool for doing the power system studies. And the last one is SIME. So that is for mainly for planning and operation of this power system. So we have more than 2,000 customers around the globe. So these are the some of the main customers who is using JMAG all over the globe. So we have our offices in Europe, France, headquarters in France, and our office in India are located in Bangalore and Chennai. And we have also offices in Michigan, and also in California, and also in Canada and Germany. So without wasting our time, we'll start with this particular function tutorial. So we can see here the contents are divided into the following points as shown in the figure. So it will start with the problem definition. So we'll go through the function description, analysis model. Then we have the methodology to create this winding. And in the methodology itself, we can subdivide this into 4. The first one is creating circuit. The second one is adding the winding, selecting the region, setting the winding, and the last 2 are for assigning the FEM conditions. That we can see that FEM conditions will be assigned for the particular geometrical models which we have created. and also we can have a small demo on 3D models also, that is with coil overhang portion. So basically this particular function description is used for or intended for JMAG users mainly. So by using this tool, it will help us to make a particular pattern without much difficulty in assigning the FEM conditions separately. So coming to the problem definition sessions, conventionally setting the coils in FE analysis models are complicated because in a large scale machine we have multiple number of poles or slot combinations. So there assigning these FEM coils conditions for each coil manually will be somewhat difficult. So by using the winding editor in JMAG, coil settings can be assigned automatically and easily. So coming to the function description, winding editor is a function which is available in JMAG that can automatically set coil conditions simply by setting the parameter. So we have some supported type of windings and cages here. So these are the list of windings in which we can assign this particular FEM coil condition. So that is the first one is three-phase winding, second one is polyphase winding, third one is brush motor winding, and the last one is induction motor cages. So coming to the analysis model, so we'll start with a simple analysis model here. So in the analysis, as you can see in the screen, we are only considering the stator part in order to get ease of understanding. So we'll start with this 48 slots, 8-pole motor stator structure. So here the parameter which we are specifying is the number of layers is 2, coil pitch is 5, phase resistance is 0.05 ohms, coil connection is in star, and the phase order is in UWV fashion. So as you can see in the screen, the windings which is colored with red, green and blue respectively for U, V and W phase. So as I have already explained, we are going through a particular methodology here. So we'll start with creating a circuit. So for creating a circuit, JMAG itself have this particular add circuit option in study. So since we have the inbuilt circuit editor here, by right clicking on the study, you can see two options. The first one is adding circuit and the second one is import circuit. So this JMAG circuit editor includes the winding, three-phase coil and cage components. So that particular components can be linked and can be used for automatically assigning the FEM coil conditions for the particular magnetic field analysis. So as I have already explained, we are only considering the stator part for assigning these conditions. So coming to the circuit option, here we can see here we have, as I have already mentioned, we have three-phase winding and multi-phase winding. So you can see the winding with number 3. So either you can select that particular component or you can select the multi-phase winding, that is denoted by alphabet N. So by clicking on the winding three-phase coil, we can see and place the component and select the type of coil connection. So as you can see in the screen, by clicking on the 3, I can click on any arbitrary position in the circuit editor. So that particular winding three-phase coil will be placed there. So again, by double clicking on the winding three-phase coil component, you can select the type of connection, whether it's star or delta, you can change that accordingly. So this is how you can place a winding three-phase coil. So other than that, we have one more component called macro. So in the leftmost portion, the top position, you can see a macro component. So by selecting on that also, we can create a three-phase connection for default star or delta connection. But for this particular coil connections or automatic winding option, you need to use this winding three-phase coil option. So by placing that, we are able to change the type into star or delta. So coming to the second step, we will be going through the add winding option. So here again, right clicking on the study, you can see add winding option here. So by clicking on the add winding option, a particular section will be opened in our project model. So under the project manager, you can see the 2D models. A study will be created. So under that particular study, you can see the winding. So under the winding, there are two regions. The first one is a region setting and the second one is winding settings. So we need to identify the regions first, and later we will assign with the winding settings in that. So we are going to the third section, and that is the selecting regions option here. So here this is how it will look like. So region settings is nothing but just right click on the region here. So it will open a window to add a new region. So here, once the new region is added here, you can see the parameters which can be inputted into the particular project manager window, the model window. So here you can see the title, so you can rename that. And in the region part, you can see the number of slots and poles can be inputted there. So under that, so since it is a 48 slot 8 pole machine, you can directly input the value into that particular column. And you need to select the coil region 1 and 2. So you can see the enlarged view of this particular stator combination. So by clicking on the coil region 1, you need to select the particular coil region 1, and by clicking or selecting that coil region in the model, it will by default it will select the regions. And in coil region 2, you just select or click on the coil region 2, and simultaneously you just click on coil region 2 in the model stator model also. So by using these two options, you can simply select these two coil regions. So once these two regions are selected, so as you can see in the screen, coil region 1 and coil region 2 are selected here. So once the regions are selected, it will automatically show the total number of slots and that combinations of winding which is available in that particular combination, particular stator geometry. So here you can see, since we have assigned the 48 slot or 8 pole machine combination, you can see the windings or regions are starting from slot number 1, and it is marked till slot number 48. So this is how it will look like once we create a particular what we can say the regions here. So the selected regions will be highlighted with the slot numbers, and since it is a double layer, it will also indicate the next layer. So the last step is nothing but the winding setting. So we will set the winding properties here. So as you can see in the screen, already I have mentioned that we have two different subsections in the winding. The first one is region setting, and the second one is winding setting. So in the winding setting, just right clicking on the winding. So you can see four options here. So the first one is add three-phase winding, add a multi-phase winding, add brush motor winding, and add cage. So these four options are available here. So any of the options you can select from here. Since it is a three-phase winding, you can select the three-phase winding combination here. So if you are using an induction motor with cages, if you want to assign the cage condition separately, you can use the add cage option. So in this particular function tutorial, we are only using the three-phase winding option. So I have selected that three-phase winding option here. So a new window will be opened with coil and winding tabs in the default settings. So when I'm clicking on the coil, you can see the input items here. The phase resistance is there, number of turns, setting type, wire diameter, film thickness, number of strands, insulation thickness, slot fill factor, maximum slot fill factor, correction factor, phase resistance, leakage inductance. All these values will be visible here in the coil. And the second tab is a winding tab that will go through after assigning all these values. We'll go to the next tab, that is the winding tab. And in the model window, once you select all these details, it will show the possible combinations in which you have connected your winding. So here you can see here, I haven't assigned that conditions here. So it will look like it is starting from 1 to 2, 3 to 4, like that you can see the coils. So once we select all the details, all the parameters, you can see the particular combinations for these coils. So we'll quickly go through the input items and properties which can be inputted or considered in the analysis. So regarding the coil settings, so as you can see in the screen, the first option is input type. So if you are selecting the phase resistance value itself, you cannot see much option. You can see the other options are deactivated here. So only the options which consist of the turns, phase resistance, and leakage inductance will appear in that particular input item. So if you are changing the phase resistance type into any other type, so basically the turns per wire size or turns per slot fill factor, you can see all other things uh, in order to assign the values. So by selecting the turns per wire size, it specifies the number of turns of a coil as well as the wire cross-section geometry and size. So the slot fill factor is calculated based upon the parameter, and the following formula is used for particular input item. So here the slot fill factor is calculated like wire cross-section area plus insulation film area into total number of turns. So for all the number of turns, it will calculate the entire area, and it is divided by the slot area minus insulation sheet area. So we are not considering the insulation sheet area for this particular slot fill factor calculation. And in the second option, the second input item is nothing but turns per slot fill factor type. So in this particular input item, it specifies the number of turns of a coil and ratio of a wire cross section area to calculate the slot cross section. So the cross section area of a wire is calculated based upon the parameter which is given below. That is including film thickness, the wire cross section area is calculated. Slot area minus insulation sheet area, uh, uh, and it is multiplied with the slot fill factor, and it is divided by the number of turns. So all these are the input item or input type where we can change the combinations of what we can say the calculation method for each item. And in this third option, you can see wire size per slot fill factor. So it will specify the wire cross section geometry and size, and the ratio of wire cross section area to a slot cross connection. The number of turns of a coil are calculated based upon this particular equation. So turns is equal to slot area, and it is divided multiplied with slot fill factor, and it is divided with wire cross section area plus that insulation film area. And the last one, which I have already mentioned, that is the phase resistance input item. So here we will specify the resistance of an entire coil per phase in addition to the number of turns and slot fill factor. So this is how you can change the input item. So the first option is turns per wire size. The second input item is turns per slot fill factor. Third one is wire size per slot fill factor, and fourth one is phase resistance. So either of these input type can be specified, and corresponding values can be inputted into the window. So the input parameters which we can mention by selecting this input item are film thickness, number of strands, insulation thickness, and slot fill factor. So in this option, we have two different options for selecting the type of wire which we are using. The first one is a round wire, and the second one is rectangular wire. So the wire cross section will change. So if we are selecting the round wire, we need to mention the wire diameter and the wire size. That means that width and height of the wire is selected when you are using the rectangular wire. Coming to the film thickness, you can see, as you can see in the screen, that the insulation sheet is shown in a yellow color here. So that is for single layer and double layer winding. You can see the differentiation. So the first one is having only one coil, and the second one is having double layer coils inside. So based upon this particular sheet thickness, you can mention the film thickness here. And the number of strands, you can enter the number of wires to be made parallel. The strands can be inputted here. The third one is insulation thickness. So in insulation thickness, you can give the values directly. That is insulation thickness to prevent the contact between the slot and wire. So this parameter is especially used for calculating the slot fill factor, as I have mentioned in the previous slide. And the fourth one is a slot fill factor. So here you can enter the value based upon the input item. Based upon the input item, as I have mentioned, the slot fill factor will be calculated automatically. So the next factors which we can input into that window are correction factor, phase resistance, and leakage inductance. So correction factor is nothing but we can have the correction values. Like if the phase resistance is not matching with the actual scenario, you can use this correction factor in order to match the physical and simulation inputs. And in phase resistance, enter the resistance of the entire coil per phase, so that the resistance of the area is enclosed with dotted lines. So here you can see that for particular winding, like whether you are selecting U, V or W, based upon that you need to calculate the total phase resistance per phase. So that is a phase resistance here. So for V phase you need to add all the resistance for each for coil here. And coming to the leakage inductance part, we can input the value for leakage inductance by giving it in the leakage inductance input here. So by mentioning it, like say for an example here, one example is given. So by inputting 0.1 Henry in that FEM coil, it will act like an inductance which is coupled or which is connected to that FEM coil condition. So it is equivalent to a coil with an FEM coil. So here by inputting the 0.1 value, it will automatically take that particular value and it will calculate the leakage inductance value as per the design. So this leakage inductance value will be calculated based upon your overhang portion and other leakage parameter. So this is how it will look like once we input all the details in the winding setting. So as you can see in the screen, the winding tab will be winding tab is the second tab. So there you can input the values here like this. So this is the linking part where we are linking the circuit with the geometry. So link to winding component means nothing but we have created a circuit for three-phase winding coil. So it will automatically link that circuit with this particular geometry. So here you can mention the parallel number. So parallel number can be 1, 2 or 4 like that. You can select the parallel number. Series number will be selected automatically based upon the parallel number. And winding scheme is by default it will be automatic option. So if you want to change it into manual type, you can select the winding scheme into manual or automatic concentrated winding. So here as per our design we have selected the coil pitch is 5 and the layers are 2. So as per that particular design, our model is created here and you can see the coils are connected as per our design. So in that model geometry window, you can see three different windows. The first one is model view, second one is winding view, and third one is slot view. So once we select all these details, the FEM conductor conditions will be assigned automatically. So since it is a 48 slot machine, it will be difficult for us to manually assign all the FEM conditions for each part individually. So by using this winding editor option, you can see within a fraction of time you can complete the entire process for assigning the conditions, and JMAG automatically will assign the conditions based upon our input. So this is how you can assign the FEM coil conditions. So this will be the winding view. As I already mentioned in that previous slide, you can see the winding view. So here, since we have selected that star connection, you can see the common points of U, V and W are connected to a star point here. Otherwise, if you are selecting delta, the start winding of V will be, or the end winding of U will be connected to the start winding of V, and start winding of W will be connected to the end winding of V phase. So in this fashion, you can create and you can check how the coils are connected. So if you are changing the number of parallel or series number, this combination will change. Here, since we have selected the parallel fashion, all the coils are connected in a seriously. Parallel number is 1 here. So all the coils, 16 coils are connected in a series fashion. And this will be the respective slot view for our particular motor. Here you can see U, V and W phases are connected as per our design. Starting from 1 to 48, the slots are filled with the coils. And if you want to change U, V or W, or you want to hide anything, you can click on that and you can see only that phase. And so we will quickly go through that demo which I have explained just now. So this is our model. So in this model you can see the study. So I am adding a circuit here. Right click on the study, add circuit. So here as I have already explained, you can see winding three-phase coil, winding multi-phase coil, and also the winding cage option. So by selecting the winding three-phase coil, you can simply place that winding coil. So in the actual circuit, you need to give that current source or voltage source also, but since this is for a demo purpose, I am not connecting that. So here by double clicking on the winding three-phase coil, you can see whether it's a star connected or delta connected one. So as per our design, I am selecting star connection here. So just minimize this, right clicking on the study here, right clicking on the study, you just add winding. So a winding section will be created as per the input. So here right clicking on the region, so you can see the add region option. So just click on the add region option here. So our design is having a 48 slot. So here I'm just giving a sample name, sample one. So the input is 48 slot. It's an 8-pole machine. So here you can see I can select coil region 1 or 2 by clicking on the column here. So I just selected this coil region 1. So here you can select the coil region 1 here. So as per the design, the slot is selected here, and just click on the coil region 2, and here you can click on coil region 2 here. So the entire coils will be selected, and it will automatically circulated as per the rotation axis. So here you can see I have selected the rotation axis with reference to my reference point, that is x equal to 0 and y equal to 0, that means origin. So with reference to origin, I have circulated this entire pattern here. So this is how you can give the value. So once you click OK, the regions are set here. So by clicking or placing your cursor on sample one, that is our default model, you can see the fashion, particular arrangement here. And here you can see the winding settings. So just add three-phase winding. So as I have already mentioned in that previous slide, you can see the coil tab and winding tab. So here you need to mention the phase resistance value. So by clicking on either of these input item, that other values will be changed. So by selecting only the input item as phase resistance, you can fill the number of turns, phase resistance, and leakage inductance value. But if you want to input all other details, you can select either of the three input item: turns per wire size, turns per slot fill factor, and turns wire size per slot fill factor option. So I am selecting this phase resistance option here. So in our design, we have given the values as per this coil pitch is 5. So phase resistance is 0.5, 0.05, and you can mention the specific number of turns as per your design. And leakage inductance, if you have that value of calculated leakage inductance, you can mention it in the given option. And coming to the winding option here, so this is a place where we can mention the link between the circuit components. So this is the winding three-phase coil option here. So as you can see in the screen, we have created that winding three-phase coil in our circuit. So it will automatically link that circuit with reference to this model. And parallel number is 1 by default. The winding scheme is automatic, and the layers are double layer, and coil pitch given is 5. So as per the design, you can see the coil pitch is 5. So that entire phase coils are connected with reference to our input. So either you can use this, or you can use maximum coil pitch with reference to your design. So if you want to change the pattern in a reverse manner, you can click on reverse, go and return. So that entire pattern will be changed upon the design. And this is where we can mention whether it is a UWV fashion or UVW fashion. So you can change that also. And coming to the winding, as I have already explained, you can see the winding patterns here. So if you want to see only the U phase for slot view, you can click on U, and if you want to see V, you can see that, and the W phase can also be shown like this. So you can see how the coils are going from one slot to another with reference to your design, and all the inputs will be displayed on the top like 48 slot, 8 pole and 3 phase machine. So this is how you can create, and once you click OK, this will be created. So you can see here within a fraction of time you can set all the windings. So otherwise what you want to do is you need to manually create all the windings. Say for an example, I'm duplicating this study. So I'm deleting that winding option here. So circuit will be common for both of this option. So by selecting that conditions from FEM coil, you need to drag and drop this into each coil. Say for an example, you need to set the coil, you need to link it, and you need to create each parts per coil, and you need to assign the upward or downward connection. So all this will take some time in order to be get completed. Since it is a 48 pole machine and it is having a double layer winding, it will take huge time for us to do all these things manually. So instead of that, by assigning it with automatic option, it will considerably make the process easier. So this is how you can create that, and once it is done, you can see under the winding, you can see the FEM coil. U, V and W phases are selected. So when I'm placing my cursor on U, V and W, that particular coils are selected based upon our input. You can see that highlighted portions. So this is how you can create designer automatic winding for a 2D model. And similarly, you can create for 3D model also. So in 3D model, we are doing the same process only. So here you can see we have created, or we have gone through all these steps. And coming to the 3D IPM motor model, so we have just opened one model for an IPM motor. So there you can see the number of poles 4, number of slots 12, layers are 2. So this is for our understanding purpose. I have selected one random model. Coil pitch is 3, phase resistance is 0.5 ohm, and coil connection is star, and phase order is selected as UWB. So for this particular model with overhang portion, I need to assign the conditions. So for that, what I need to do is I need to just open that model. So similar to the process what we have done, we need to add a circuit with cases winding 3-phase coil here. Just minimize that after connecting coils and other voltage sources or current source. So just click on this add winding, add region. So here you can see our slots are 12 and number of poles are 4. And since our model is having coil end portion, you can click on model has coil end option here. So just click on the coil option here and select the first coil here. So by selecting the first coil, it will automatically detect coil 2 and coil 3 by default, as you can see in the screen. And you can select this option detect automatically from coil region 1 option for selecting the other sets of coil. So you can see that here. Sorry. So that other set of coil is selected here based upon our input. So this is how you can select the coils here. So just click OK after doing this. So now next is adding 3-phase option. So here as per our input, you need to enter the values. So here 0.5 ohms. The number of turns are 15. And phase resistance is given for the particular input. And in the winding, you can link that part. Parallel number will be 1 by default. Otherwise, you can change as per your design. Automatic winding is selected, and here the coil pitch is 3 as per our design. So this is how it will look like when you are seeing the winding option here. So the model view and slot view will be like this, as you can see in the screen, and the phase order is selected as UWV. Just click OK. So as per the design, you can see the coils are assigned with FEM conditions, as you can see in the screen. So this is how you can assign FEM coil conditions for a model with overhang portion also. So otherwise, manually when we are doing, you need to assign the coil condition with reference to edge or face, perpendicular to face or perpendicular to edge, like that we need to assign the coil condition for each of this coil. So instead of doing that, within a minimum time, you can assign all the FEM condition like U, V or face, W face for our model. So this is how you can do that analysis. So coming back to the slide again. So we have gone through 3 steps, 3 simple steps. So the first one is just to identify the coils which are coming under the U phase, V phase and W phase, which is assigned with, you can assign the colors also. And in the second step, you can select only one coil, that is a coil 1, and it will automatically identify other coils by default. By selecting the coil 1 itself, will select the 2 and 3 coils. And in the coil region 2, by selecting on the automatically detect option, it will select the other sets of coil. And once you input all the details, you can see the FEM coil conditions will be assigned automatically after getting or after setting the parameters. So this is how you can set all the coil conditions for 3D geometry also. So this is all about this function tutorial or function with reference to this winding editor. So thank you all for attending this function tutorial demo. So you can contact us for any other clarification in assigning this FEM coil conditions and also related to any other queries. So just feel free to contact us. So if you have any queries, you can share your queries to our mail ID jmagsupport@powersys-solutions.com. So thank you for attending this workshop, this session once again. So for any other queries related to the software evaluation or any other doubts which is related to software, you can contact us in this particular mail ID. And feel free to register for our upcoming webinars in powersys-solutions.com. Thank you all. So if you have any queries, you can share it in the chat box.
Joseph, yeah, Sadiq here.
Yeah.
Joseph, actually, I see we have 2 queries in the questions box.
Okay.
So if you can see that, it is from Ivan.
Okay.
So he has asked whether is it possible to create a wave winding with this feature. That is first query.
Okay. Yeah, actually,
and the second query is that,
yeah, please.
If we have a single layer winding, then we can only choose one coil region. That is his second query.
Yeah. So
one is with respect to single layer winding, then other one is whether we can do a wave winding with this feature.
Yeah. So here for brushed motor also it will support. So as you can see in the screen, so I'm just selecting brush motor also. So here we have the option for adding a brush motor type also here. So as you can see in the screen, I can add a I'm duplicating the study now. I'm just assigning the new winding option. So a new winding is selected here. So here just select this 1 and 2, sorry. For the time save, I am just selecting that. So here you can see this options here for the brush motor. So since we have selected that, it is not showing that. So here you can select the type here. since it is particularly for IPM motor, it is not showing that. But here we have the option for selecting the winding type in winding brush motor. So this is also supported here. Either you can select the lap winding or wave winding. So based upon that, you can mention that particular area or region in our motor model also. So this is how you can select that winding and input items for lap and wave winding. So this is related to brushed motor. And similarly, you can this second question is for single layer winding, right? So for single layer winding also, you can avoid the second coil. So you can just leave that second space and you can use it for second coil. Say for an example, in the region, you just avoid this coil region 2, and you need to assign only that coil region 1 part. So it will automatically detect other parts also. You can leave the coil region 2 as it is instead of assigning anything into coil region 2. So this is how you can do that. Okay, so thanks for that, Corey. Yeah. So anything else, Sadeep? Hello, Sadeep.
Yeah, another thing was how can you do that in a single layer winding?
Yeah, that I have already answered. You just need to only select the coil region 1 itself instead of selecting the coil region 2. So you can avoid that coil region 2 as blank. So it will automatically assign it for only single phase winding, single layer winding. So that is how you can change that. And you can manually select. Here you can see that in winding setting, you can see that we have the layer equal to 1. So you just select the layer 1 and you can avoid that regions which we have explained before for double layer winding, that you can avoid, and you can simply select 1 and you can select only one coil region. So that is how you can change that. Okay, so any other queries? And please note that actually for some motor which is having manual connection with different coil pitch, that may not be supported in JMAG designer for assigning the 3D FEM coil conditions. In sometimes the coil which will be different for each slot or each winding. So in that case, it won't be supported in this automatic winding option, because by default it is selecting one coil pitch, and that is an input item, and after that it is not it may not work beyond that. So anything else you can share in email also, so we'll be answering for that questions. Hello, Sadeep.
That's it. I don't see any other queries.
Okay. So please feel free to contact us. So you can contact us in JMAG support at powersys-solutions.com. So we'll be answering all your queries through personal mails. So for any detailed information, you can contact us. So thank you all. Thanks for attending this session. So hope you got some idea about this binding editor. So thank you all. Thank you.